Hello students, we are going to discuss paper 10 today. The topic was plane progressive waves and sound waves. In the first question, the frequency of wave is given as 500 Hz and velocity of sound in air is 350 meter per second. We want to find the distance traveled by the wave in the time the fog has made 125 vibrations. First, we will find the time taken by fog to make 125 vibrations. The frequency is 500 Hz. That means 500 vibrations are made in 1 second. So time taken for 125 vibrations will be T is equals to 125 divided by 500 seconds. Now speed is equals to distance upon time. So distance traveled will be speed into time. Speed is given as 350 meter per second and time is 125 divided by 500. Simplify this, we will get answer 87.5 meter. So option 1 is correct option. In question number 2, the equation of a plane progressive wave is given as y is equals to 4 sine of 200 pi t minus pi x by 25. We want to find the wavelength and velocity of wave. Here, comparing the equation with y is equals to e sine of omega t minus kx, we can write omega is equals to 200 pi and k is equals to pi upon 25. But k can be written as 2 pi by lambda. So pi will get cancelled out and lambda will be 25 into 2, that will be 50 centimeter, so 0.5 meter. Now omega can be written as 2 pi f is equals to 200 pi. This pi will get cancelled out, so f will be 100 Hz. The velocity of wave can be given as f lambda, so 100 into 0.5, that will be 50 meter per second. So wavelength will be 0.5 meter and velocity will be 50 meter per second. So option 2 is correct option. In question number 3, the transverse wave equation is given by y is equals to y naught sine of 2 pi f t minus 2 pi x by lambda, and it is given that the maximum particle velocity is equal to 4 times the wave velocity. Then lambda can be represented as, here maximum particle velocity can be given as v max is equals to a omega. Here amplitude of the wave is given y naught and omega can be written as 2 pi f. So y naught omega v max, and particle velocity or wave velocity is given by f lambda. It is given that v max is equals to 4 times of v, with this value y naught into 2 pi f is equals to 4 times f lambda. Simplify this f will get cancelled out 2, so lambda can be written as pi y naught divided by 2. So option 2 is correct option. In question number 4, the transverse wave along a string is given by y is equals to 2 sine of 6 pi t minus 2 pi x plus pi by 4. Here x and y are in centimeter and t is in second. We want to find the acceleration at x is equals to 4 centimeter and t is equals to 1 second. By differentiating this equation with respect to time, we will get velocity. So v will be dy by dt. Differentiation of sine will be cos of 6 pi t minus 2 pi x plus pi by 4. Differentiating again thus with respect to time, we will get 2 into 6 pi. So v will be 12 pi cos of 6 pi t minus 2 pi x plus pi by 4. Differentiating this velocity again with respect to time, then we will get acceleration. So E will be dv by dt. The differentiation of cos will be minus sine of 6 pi t minus 2 pi x plus pi by 4. Differentiating this again with respect to time, we will get 12 pi into 6 pi. So acceleration will be minus 72 pi square sine of 6 pi t minus 2 pi x plus pi by 4. We want to find acceleration at x is equals to 4 centimeter and t is equals to 1 second. Put these values in this equation. We'll get a is equals to minus 72 pi square sine of 6 pi minus 8 pi plus pi by 4. So a will be minus 72 pi square sine of pi by 4 minus 2 pi. This will be pi by 4 minus 180 degree. So it will give us a is equals to minus 72 pi square sine pi by 4, and sine pi by 4 is 1 by root 2. So minus 72 pi square into 1 by root 2. So acceleration will be minus 36 root 2 pi square centimeters per second square. So option 3 is correct option. In question number 5, two wave equations are given. Y1 is equals to 5 sine of 2 pi into 10t minus 0.1x, and y2 is given as 10 sine of 2 pi into 10t minus 0.1x. We want to find the ratio of intensities, that is I2 by I1. The intensity is directly proportional to amplitude square. So I2 by I1 can be written as A2 by A1 whole square. Here amplitude of second wave is 10 divided by 5 whole square. So I2 by I1 will be 4. So option 3 is correct option. In question number 6, it is given that a wave has a frequency of 120 Hz. 2 points, let's say A and B, are 9 meters apart and they have phase difference of 1080 degree. We want to find the velocity of wave. Velocity of wave can be found by using formula v is equals to f lambda. For that, first we have to find wavelength lambda. For given wave, if path difference between 2 points P and Q, the path difference between 2 points P and Q is lambda, then phase difference will be 2 pi, that is equals to 360 degree. So 1080 divided by 360 degree will give us 3. That means between points A and B, we are having 3 waves. So total distance will be equal to 3 lambda, and 3 lambda is given as 9 meter. So lambda will be equal to 3 meter. Now V is equals to f lambda. F is given as 120 Hz and lambda is 3 meter. So velocity will be 360 meter per second. So option 4 is correct option. In question number 7, it is given that a plane progressive wave has frequency of 25 Hz and amplitude 2.5 into 10 power minus 5 meter. The velocity of wave is given as 300 meter per second. We want to find the phase difference between 2 points located 6 meter apart. We know frequency and velocity. From that we can find the wavelength. V is equals to f lambda, so lambda will be v by f. Velocity is 300 divided by 25, so lambda will be 12 meter. As we have seen in previous question, the phase difference between 2 points having path difference lambda is 2 pi. So for 12 meter path difference is 2 pi. So for 6 meter path difference will be pi. So option 1 is correct option. In question number 8, two simple harmonic motion are represented as y1 is equals to 0.1 sine of 100 pi t plus pi by 3 and y2 is equals to 0.1 cos of pi t. We want to find the phase difference of velocity of particle 1 with respect to velocity of particle 2. For that we have to write the equations for velocity. So v1 can be written as dy1 by dt, that will be 0.1. Differentiation of sine will be cos 100 pi t plus pi by 3. Differentiating again with respect to time will give us 100 pi. So v1 will be 10 pi cos of 100 pi t plus pi by 3. v2 will be dy2 by dt, that will be 0.1 pi minus of sine pi t. To find the phase difference, this both equations should contain same trigonometric function. Here this function is cos, this is sine. We can convert it. So v2 will be minus of 0.1 pi cos of pi by 2 minus pi t. So phase difference will be, phase difference in velocity 1 with respect to velocity 2 will be pi by 3 minus pi by 2, that will be equal to minus of pi by 6. So option 1 is correct option. In question number 9, the Young's modulus of material of rod is y and its density is rho. We want to find the time taken by the sound wave to travel L length. Here speed through the rod can be given as v is equals to under root y by rho, and speed is equals to distance upon time. So time t can be written as distance L divided by speed y by rho. So t will be L under root rho by y. So option 1 is correct option. In question number 10, the amplitude of wave disturbance is given by y is equals to 1 upon 1 plus x square at t is equals to 0, and y is given as 1 upon 1 plus x minus 1 whole square at t is equals to 2 seconds. We want to find the velocity of wave. Velocity of wave can be found by x2 minus x1 upon t2 minus t1, that is distance traveled by wave divided by time interval. From this equation we can find x1, and from this equation we can find x2. So y is equals to 1 upon 1 plus x1 square. So 1 plus x1 square will be equal to 1 divided by y. So x1 square will be 1 by y minus 1, that will be 1 minus y divided by y. So x1 will be under root 1 minus y divided by y. Same way we can find x2 from this equation. So 1 plus x2 minus 1 whole square is equals to 1 by y. So x2 minus 1 whole square will be equal to 1 minus y by y. So x2 minus 1 is equals to under root 1 minus y by y, and x2 will be 1 plus under root 1 minus y divided by y. So wave velocity will be x2 minus x1 upon t2 minus t1. Here from this equation we can write x2 minus x1 will be 1 and t2 minus t1 will be 2 minus 0, that will be 2. So v will be 0.5 meter per second. So option 2 is correct option. In question number 11, it is given that the pressure of air increases by 100 mm of Hg and the temperature decreases by 1 degree Celsius. We want to find the change in speed of sound in air. The formula for speed of sound in air is given as under root gamma p by rho is equals to under root gamma RT by m. From this equation we can see if pressure is increased then volume will be decreased, and if volume is decreased density will also be increased. So if pressure is increased by the same amount, density will also be increased. So we can say that speed of sound in air is independent of change in pressure or change in density. So speed of sound in air is directly proportional to root t from this equation. Now we can write v2 by v1 is equals to under root t2 by t1. We want to find the change in speed of sound in air, that is v2 minus v1. v2 by v1 can be written as under root, let's say t1 is 273, so t2 will be 273 plus 1, this is room temperature or 0 degree Celsius. So t2 will be 274 divided by t1 273. So v2 will be v1 under root 274 divided by 273. Put the value of v1 as 330 meter per second. We will get v2 as 330.6038. So v2 minus v1 will be 0.6038 meter per second. So approximately the change in speed can be written as 61 centimeter per second. So option 3 is correct option. In question number 12, it is given that the speed of sound in oxygen at certain temperature, let's say T, is same as speed of sound in nitrogen at temperature 15 degrees Celsius. We want to find this temperature T. The speed of sound in gas is given by under root gamma RT by m. As oxygen and nitrogen both are diatomic, so gamma will be same for them. So we can write V is directly proportional to under root T by m. So speed of sound in oxygen divided by speed of sound in nitrogen can be given as T divided by temperature of oxygen divided by temperature of nitrogen into mass of oxygen, mass of nitrogen. So VO by Vn is equals to under root TO. The temperature of nitrogen is 273 plus 15. The mass of oxygen is taken 16 and mass of nitrogen is taken 14. Here it is given that velocity in oxygen and velocity in nitrogen are same. So we can write 288 into 16 is equals to T naught into 14. Simplify this, we will get T of oxygen is equals to 329.14 Kelvin. So temperature will be 56.14 degree Celsius. So option 2 is correct option. In question number 13, we want to find the ratio of speed of sound in nitrogen to the speed of sound in helium at temperature 300 Kelvin. Speed of sound at gas is given by under root gamma RT by M. The temperature for both the gases is same, so we can write V is directly proportional to under root gamma divided by M. So velocity of nitrogen divided by velocity in helium is equals to, as nitrogen is diatomic, gamma for it will be 7 by 5 into mass of helium, that is taken as 4, divided by, as helium is monoatomic, gamma for it will be 5 by 3 and mass of nitrogen is 28. Simplify this, we'll get Vn by Vhg is equals to under root 3 by 5. So option 3 is correct option. In question number 14, it is given that a copper wire is held at the two ends between two rigid supports at 30 degrees Celsius. The wire is just taut with negligible tension. The Young's modulus is given as 1.3 into 10 power 11 Newton per meter square. Alpha is 1.7 into 10 power minus 5 per degree Celsius. And density of copper is given 9 into 10 power 3 kg per meter cube. We want to find the speed of transverse wave in this wire. The speed of transverse wave in stretched wire can be given as under root T by mu, where T is the tension force and mu is the mass per unit length, that is linear mass density. Here the tension force will be created due to thermal stress. So tension force can be given due to thermal stress is equals to Y A alpha delta theta. T divided by mu. Mu is mass per unit length. So we can write YAL alpha delta theta divided by total mass M. Area into length can be written as volume, so it will be Y into volume alpha delta theta divided by M. If we rearrange this formula, Y alpha delta theta divided by mass by volume. Mass upon volume can be written as density, so T divided by mu will be equal to Y alpha delta theta divided by density. So V will be under root Y is given as 1.3 into 10 power 11, alpha is given 1.7 into 10 power minus 5 per degree Celsius. Delta theta, initially the temperature was 30 degrees Celsius and we want to find the speed at 10 degrees Celsius. So delta theta will be 20 degrees Celsius divided by density, that is given as 9 into 10 power 3 kg per meter cube. If we simplify this, we'll get velocity is equals to 70 meter per second. So option 2 is correct option. In question number 15, a standing wave set up in a medium is given by equation y is equals to 4 cos of pi x by 3 into sine 40 pi t, where x and y are in centimeter and t is in second. We want to find the velocity of medium particle at x is equals to 6 centimeter and t is equals to 1 by 8 second. To find the velocity of particle, we have to differentiate this y with respect to time. So v can be written as dy by dt. So 4, here cos is function of s, x that can be treated as constant. So cos pi x by 3. The differentiation of sine will be cos 40 pi t, and differentiating 40 pi t again with respect to time will get 40 pi. So velocity will be 160 pi cos pi x by 3 into cos of 40 pi t. We want to find the velocity at x is equals to 6 centimeter and t is equals to 1 by 8 second. Put these values in this equation. So velocity will be 160 pi into cos of pi x is 6 divided by 3 into cos of 40 pi by 8. So velocity will be 160 pi cos of 2 pi and cos of 5 pi. The value of cos 2 pi is 1 and cos 5 pi is equals to minus 1. So put this value, we'll get v is equals to minus 160 pi centimeter per second. So option 4 is correct option.